business guys. And our, I think Nicole said the engineering technology, I was an ID major, so I'm right below that. It's real simple to me. I'm like, here's the power plant that you want to, here's what's one of the consumer. You've got a bunch of land up here, why don't we just build a transmission line? Well, it turns out there's farmers in between here. And oh, that's a minor issue because now you're trying to communicate really something complex to a guy that he graduated from the College of Ag, which is a great, we have some awesome programs here. I took a few when I was here. But my point is that this is really complex and it needs guys like you. So I go to somebody else and I say, prove up and tell me the cost of that transmission line. And tell me that it's going to be able to support it, to make sure that even in a short distance that I build it with enough insulative capacitors, or I have reactive capacitance. All these terms that the ERCOT engineers just confuse the heck of me out of. And I have to go look up what the heck they mean. And then I call Natsu and I try and can tell him, look, it's a low-risk project, give me some money. He says, no, hire EPE to tell you why it's good and prove it up. And so my point is that this is where the engineering starts to come together and really make things sense. But it also is uneconomic. Does anybody know how much it costs to build a transmission line? A 69 kV, which is one of the more common types of size transmission lines, per mile?
Million per mile, or $1.5 million.
On a 69 kV, it's $125,000 a mile, roughly. But it's also commodity-based, because does copper stay the same price? No, it moves like this. So whether you're in building pipelines or building transmission lines, the output is can be the same, but the cost of it varies. Yes, ma'am?
So I'm just a little confused about the transmission issue, because everything has said it's really expensive, but I mean, I don't really know who does it, but you know, like in a city, when you put power lines and just, like it's kind of not done by individual small consulting businesses, it's done by like the city or the state. And so why is it that it's a real big problem for when individual companies try to do it, but it's not a really big problem when people just don't seem to care when the state or the city does it? You know what I mean?
It's a very long answer to your question that I will take offline, but the simplistic kind of response is that it's somewhat market driven. And what I mean by that is that ERCOT, which is the operation for the majority of Texas, kind of the Dallas, Fort Worth, Midland, pumps over there, is its own power grid. It's its own RTO, regional transmission operator. And they're the big grid manager, right? I'm standing above everybody and I move power here and manage it all, make sure it doesn't go down. And so the short answer is that some RTOs charge the developer that, and the developer has to recoup that in the form of his costs. Other RTOs say, look, we want to create an efficient market, which is what Wall Street loves, because it allows for a lot of buying and trading. And so ERCOT says it's in the best interest not just of oil and gas, but of all transmission, that we rate base this or spread the cost evenly across all types of generation. And so ERCOT rate bases the pay, meaning we all collectively pay for it. It's also known as socialism. but again, regardless of your opinion about that, it's just how some market guys choose to execute things. So there's a much more in-depth answer that we can, I'd probably get lost in trying to explain, but we can dig in if you want to. Yes, sir?
I'd like to add some insight about, you said there's a lot of farms in between. I watched this video of some folks in wind farm. They were going to build a transmission line from Canada to California through a bunch of farms in the north.
Right.
And they couldn't understand why the farmers didn't see it their way and what the problem was with transmission lines and so on and so forth. And they tried to explain to them and said, look, this is how it is. This is the size of our equipment that we're dealing with. And so they brought down all the executives of the company to come in this parking lot. But one of the farmers decided to bring his planer, which is 60 feet long,
right,
sit it right in the middle of the parking lot where they didn't have a parking spot.
Yeah. And
he showed him, said, this is how I have to deal with this. If I have to drive, I'm supposed to drive straight lines to maximize my field efficiency.
Yep. And
then if you plant this here, I got to curve around.
Yep.
I'm losing thousands of dollars a year just
Absolutely.
For that. Not only that, to fold it up, I can't even go underneath your power lines. I got to go around everything just to get to the other side of the field.
Sure.
I mean, I think that's another thing that that some of the energy departments and other engineers need to kind of think about it, just the different impacts it has on some other folks.
Couldn't agree more, and if they don't, they're idiots. Yeah. Couldn't agree more. And if you aren't responsibly planning, there's plenty of, the sad part is it's not illegal to be an idiot or ignorant. So, you know, if I show up dressed in a three-piece suit in Windthorst, Texas, if I'm asking for a tax abatement, I need to. because I'm asking for $1 million and the superintendent of the school district wants to know I look the part. But if I'm going to talk to the farmer and say, can I run an easement underground, you'll never see it through your land, I better not show up in a three-piece suit. That's a crude example, but I couldn't agree with you more.
But I mean, that farmer has, you know, a local town, like he goes and buys food and his clothing and whatever, and that town is powered by power lines, and the electricity to his house is powered by power lines, and people don't mind power lines going through their businesses, their homes, their land, whatever, but as soon as it's for a wind thing, they're like, oh my God, now I want money to rent land.
Well, I'm going to disagree with you on that. They do mind. What you don't know is very expensive, and I'm just saying be cautious about that because people mind a lot, especially in high dollar subdivisions like Highland Park in Dallas. Try to put a power line through there, they'll mind. So I'm just cautious. Avoid making, I did it a lot, especially because I'm like a boisterous, charismatic individual, some would say. Avoid making generalized statements, especially when you're still in school. I did it far too much. Yes, sir.
Just a comment, actually as a project engineer for Horizon Wind.
Sure, yeah.
And I built a couple of wind farms in different places.
Right.
And it's, you know, you're talking about all those different people you have to talk with and play the different parts. And to your point about understanding where everyone is coming from. We had an individual that came in hooping and hollering and yelling and cussing at us. I mean, so bad, it was in the middle of Minnesota, so bad that he wouldn't even shake our hand, which, you know, when you get to rural areas, that really means something.
Absolutely.
And so all it was taking the time to go out there and really understand what his issues were. And, you know, we talked for about 3 or 4 hours. I mean, was not my job as far as an engineer, you know, it was, I mean, but any kind of industrial movement. If you go talk to, I mean, I'm from West Texas, so sure. We grew up on oil and gas. You go talk to an oil and gas developer, you know, you go try to say you can put a derrick on somebody's land, which they've loved for, you know, generations, and it should be corn there, or should be, you know, cotton or whatnot, and not some piece of machinery. You go out there and say that without respect of their generations and their lands, you're really doing yourself a disservice.
Absolutely.
So it's most important to understand where each of those, like you said, maybe the school teacher or the farmer or whatnot.
Yeah, I couldn't agree more. It may look like raw land to you, but it's someone's domain. It's the equivalent of putting a power line through your apartment to some people. That probably wouldn't go real well with, you know, whoever governs the utility. So anyhow, we're almost done with the engineering portion. So another thing that's important to engineer, it's a different type of engineer. Nicole, you said you're an aerospace engineer. So you know anything about the FAA?
Of course.
Okay, so they have some pretty cool, they want to know what goes on. So another really cool thing, I didn't realize until we got 7 months into an FAA process, that in South Texas, and by the way, time in business is money. You may not realize that because you're just students and everything's great and you just worry about beer money. Time in business is money. And so airports play an important part. Without boring you on this, there's a lot of engineers at the FAA. We hire aviation consultants that are hired brilliant aerospace engineers that we pay money for at about $5,000 a study to tell us, not just, I mean, we know where they are. This is a Google Earth layer. This is a snapshot from Google Earth with all of the airports in the country that we have. It's really kind of cool. But they tell us what is the likelihood of the impact and all this sort of stuff. And one of the things I learned in South Texas is that, fun fact for the day, there's an over-the-horizon radar that slowed down a lot of the permitting and wind farms in South Texas. There's nothing in South Texas except for desert. It's former desert. And it's brush and rattlesnakes and deer hunting. But there's an over-the-horizon radar that the government won't really tell you about that looks across the entire Caribbean for drug running and for all those things that, oh, a wind farm might impact. So there's a role for you if you like that sort of thing in engineering. Here's an example of that. This is on the FAA website. You can pull this up if you type in your spot and you want to tell them I want to put a wind farm here. They'll tell you, here's the spot I was consulting on, and they'll tell you what is your risk and your probability. So this is where policy comes in because, some of the greatest build out of the wind business happened under a very conservative President, George W. Bush. So it also is happening under Obama, but not as much because the economics aren't as good. I'm not here to take a position on economic policy, but my point is that policy affects this. This is where policy and engineering come together. So Colonel David Bellotti, the former base commander at Nellis Air Force Base, a home of a 14 megawatt solar installation, now heads up the DoD Wind Energy Clearinghouse, who ruled on South Texas. And it's really cool because I got this great relationship with this guy. And we brought an engineer because we didn't know what we were impacting. And sure enough, the engineer, which Mad Sue will eventually lend us money against his report, told us that, oh, it's yellow, it's moderate risk, we need to quantify it, and for a long-range radar, you're okay. Yes, sir.
Yeah, I would like to add some comments here because I'm working on the wind blade, and it said now they developed a new blade, which could not impact the radar. So I think that's a new way how we through the engineering to interact with the policy. It just improve the technology.
Yeah, that's a huge. One of the greatest areas for improvement that, if you're with the venture capitalists, the reason venture capital, these are the really smart guys that made it well somewhere else that have cajillions of money. So when they give a couple million over here, it's only they got a big pool back here to pull from. They're giving a little bit over here. The reason they're making investments in this sort of stuff is that the technology is so great for improvements that such that wind it competes pretty well right now, but it could really compete and lower the cost of a lot of things just by improving the technology. That's why solar has so much room to grow, and even wind. Because if you look at it, oil and gas technology, until fracking was developed by the 80s and by George Mitchell, who, the Mitchell Tennis Center out of here at A&M, that's him, really brilliant Aggie engineer, so you guys should feel great. Harvard's got nothing on him. Seriously, MIT, Harvard, Stanford, Yale, they're nothing on George Mitchell. That guy's a genius. And oh, by the way, he understands energy and business and policy. And he can do whatever the heck he wants now. Because he developed this really cool thing and stuck with it when no one else would listen to him. It's a great idea of fracking. And now it's revolutionizing the industry. Similarly, that's happening in solar. But think of how long oil and gas existed before fracking came along quite well. 70, 80, 100 years. Ever heard of Rockefeller or Carnegie if you read that book? My point is that wind and solar from a technical point of view, engineering point of view, was driven by the tree huggers. Guys that said, la, 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 I don't care if it makes economic sense in California for years. And so from an engineering point of view, that's the most exciting part about our industry. Because there's so much room for improvement. Fracking's been around since 1980, but it only became commercial because they took that long to optimize it. And so that's why stable policy, that's why all of these things, they're so important for the long term, because we either stick our head in the hole, in the sand, and just hope it's all going to go away, and don't let you guys dream up the next greatest thing. We'll just wait for gas to go to $6, as opposed to go back to 78 cents, like I'd love it. So this is, we're getting long here, so this is another example of where engineering comes in. So this is turbine spacing. Anybody ever driven in a boat? Anybody ever water skied or wakeboard behind a boat? I have. So anybody ever had another boat come over and create a wake and you try and wakeboard across that thing and you catch a bad edge? Yeah, it's really bad.